The National Association of Education Resources estimates that 25% of all students in 2012 were non-traditional. Let me write that down. There we go. That's P. P is equal to 0.25. Reason why it's a population doesn't say anything about a sample. And then it says if a sample of 850, now we're talking about a sample. If a sample of 850, so N is 850, students in 2012 was obtained, was probably that most 220 students are non-traditional. So at most, that's X, 220. That means we shade to the left, because it's at most. It's not greater than that. Okay, and what's probability? So now that we have that set up, let me get back. I'll quit flipping around here in a second. Okay, here's our steps. So step 1. Mu sub p hat is going to equal to P. And P is given, so mu sub p hat is going to equal to 0.25. Now sigma sub p hat, that's going to equal to the square root of P times 1 minus P over N. So P times 1 minus P over N. So I got 0.25 times 1 minus 0.25 divided by N, which was 850. So let's see what that gives us. So I got second x squared, 0.25, beginning parentheses, 1 minus 0.25, closing parentheses, divided by 850, and then enter. Now you don't want to round this, so you want to take it to all the decimal places. 0.14852 2131. If you're comfortable with storing things on your calculator, you can store it in the memory. I'll just write it out, just keep this videos fairly simple. Okay, now we're at step 2. Now step 2 requires us to have p hat. So first thing in step 2 is we want to find p hat, which is x over n. Well, x is 220, and n was 850. So 220 divided by 850 gives us this value right here. 0.2588 235 294. Okay, that's p hat. Now our picture's changed now. Instead of that being x equals 220, its picture is exactly the same, but this is now value down here is p hat is equal to 0.2588 235 294. Still shaded to the left. That doesn't change. So that's what our picture looks like now. Okay, so step 2 says we need to find z. Z is equal to p hat minus mu sub p hat over sigma sub p hat. So we got p hat minus mu sub p hat over sigma sub p hat. P hat we said was a big long number, so we got 0.2588 235 294 minus mu sub p hat, which we said was 0.25, divided by sigma sub p hat, which is all of this, 0.0148522131. Now whenever you put anything in your calculator where you have more than a single number or single variable on top and bottom of your fraction, You have to put parentheses around that top, or parentheses around that part. So we'll put parentheses around the numerator. So let's see what that gives us. We'll do a beginning parentheses, 0.2588235 294 minus 0.25 closing parentheses divided by 0.014, and it's right there on my screen, 0.014852 2131, and then press enter, and we get Z. Now notice here it says round to 2 decimal places. So this one we're going to round, let's see, 0.59, 0.59. Now the reason why I say 2 decimal places here and every other place I say just round it all the way is the book goes off of 2 decimal places. So to get your answer to match the book as much as possible, you round the Z-score to 2 decimal places. That's what the normal distribution data is based upon. Now, if you took it out in more decimal places, your answer would be actually more accurate than the books. Okay, now continue up here. Now our picture has changed. Instead of it being x equals, p hat equals, and now it says z equals 0.59. It's still shaded the same way. How the picture looks never changes, just the value underneath does. Then step 3 says we're going to use one of these normal CDFs. This first one is where we're going to the right, this is where we're going to the left, and this is where we're in between 2 values. So we're going to use the second one because we're shading to the left. So we'll do normal CDF. We'll do our low value, which is negative E99, our high value, which is 0.59, and then 0, 1. And this tells us to, doesn't tell us, but we should round it to 4 decimal places. So we're going to do second vars, choose normal CDF, press 2, negative E99, so negative, second comma for the E, 99, comma, 0.59, comma, 0, 1, enter. And our answer is 0.7224.